So in this video, we will study about the internal energy in thermodynamics. So internal energy is a very important parameter in thermodynamics. It is a macroscopic quantity, like it is a bulk quantity. It is not microscopic, but the explanation is microscopic. So how internal energy a system will get? Because of the kinetic energy and potential energy of the constituents. So for the best example is, you take a gas confined in a box like this. So the internal energy is equivalent to the sum of all kinetic energies and potential energies of the molecules or atoms. Okay. Then there is a restriction for that. The box should be stationary. The kinetic energy and potential energies are calculated with respect to the center of mass of this stationary box or system. Okay. And not it is, suppose if it is moving, the entire box is moving, it will then also it will have a kinetic energy. Those things we are not considering here. So in this case, actually kinetic energy is, let us take the number of molecules or atoms m, then it is kinetic energy and potential energy roughly of each, or if you take average, then this will give you the kinetic energy of this box. And if it is stationary, suppose if this is moving, in addition to this, it will have, if the mass is m, okay, and velocity, suppose if it is moving with some velocity v, then it will have half mv square. Okay, this we are not considering. Okay, we are considering only this. So it is the internal energy of a system, and it includes only the random motion of molecules of the system. Okay, that is the thing. That's why we are not considering this. So we have to understand internal energy in that way. But explanation is microscopic, but it is a macroscopic quantity. Okay. Then there are one or two things we should know about this. One is internal energy of a system is represented by capital U. Okay, internal energy is represented by capital U. U is a macroscopic variable of the system. It is a variable. It is macroscopic. Then whatever I discussed, I am writing. If the system or box is moving as a whole with some velocity, the kinetic energy of the box or system is not to be included in U. This is an important point to be remembered. Then there are, it is a variable, it is a state variable. So that is what we are defining here. Okay, it is a state variable. That means equilibrium we discussed. So at equilibrium, if you measure it, then in equilibrium means it is stable. So that's why at that time if you measure internal energy, it is state variable. Okay, and we are not going to find out how that state has reached. Only we are interested in that state. How we have reached that state is not important in thermodynamics. Okay, so the internal energy is defined as a state variable only. Okay, similarly, if you take a gas or other systems, pressure, volume, temperature are also considered as state variables only. How temperature has come? By heating something? No, we are not interested when it is increasing or decreasing. At particular state, what is the value? And based on that values or measured values, we will do some calculations. But those things are state variables only. We are not very much worried about how it has reached or how it is varying. Okay. So remember all these things: pressure, temperature, volume also are state variables. So this is the very brief description of what is internal energy, because it is very important.